An unknown distribution has a mean of 90 and a standard deviation of 15. Let's let capital X represent the random variable with this unknown distribution. Then we can say the mean of that capital X variable is 90, and the standard deviation of that capital X variable is 15. And from this data set, we don't know how many values are in the data set. We don't even know what the data represents. We definitely don't know what the distribution looks like. We're going to take multiple samples, and each sample is going to be 25 data values. So we're going to do random samples of 25 values. That allows us to create a new variable, capital X bar, the set of sample means. This random variable, by the central limit theorem, will follow a normal distribution. If we take samples from our original random variable, calculate the mean for each one of these samples, then we know the distribution of those sample means will be normally distributed, and we also know the center of that distribution will be exactly the same as our original random variable. We are interested in calculating the probability that a sample mean from this data set is between the numbers 85 and 92. So we're looking for the probability that capital X bar is somewhere between 85 and 92. To answer this question, we'll start by finding the parameters for the distribution of capital X bar, the set of sample means. The central limit theorem tells us that we can copy the mean from the original variable as the mean of the sample means. So X and X bar will have the exact same mean, 90. Standard deviation doesn't quite work that way. We have to calculate the standard deviation using the original variable's standard deviation. So the new variable, X bar, is going to have a standard deviation that's calculated by taking the original standard deviation and then dividing it by the square root of our sample size. So our set of sample means has a standard deviation of 15 divided by the square root of 25. Now 25 is a perfect square, so when we square root it, we get 5. 15 divided by 5 is just 3. So the standard deviation for our set of sample means is 3. Now we know the distribution that our sample means data set follows. It's a normal distribution with a mean at 90 and a standard deviation of 3. So we can annotate our normal curve with our center, and we can label a few of the values along our horizontal axis using that standard deviation to go 3 standard deviations above the mean, 93, 96, 99, and 3 standard deviations below the mean, 87, 84, 81. And now I'm ready to start answering questions about probabilities, or areas under the curve. If I'm looking for the probability between 85 and 92, then I'm looking for the area under the curve between the numbers 85 and 92. To find that area, I don't have a simple formula. I either have to take multiple semesters of calculus, read a table, or use a calculator that's able to calculate that area numerically. I'm going to show you how to find the z-scores, so that way if you had to use a table you could, but also I'm going to use a calculator to determine this area. So first, let's convert 85 and 92 into z-scores. So we'll take the sample mean, 85, convert it into a z-score using the relationship x minus the mean divided by the standard deviation. So 85 as a z-score and 92 as a z-score. Now we can rewrite this as a probability relating to z-scores. Instead of asking what's the probability that a sample mean is between 85 and 92, I can ask the question, what's the probability that our data set follows a z-score between negative 1.67 and 0.67? And again, those values were found using the formulas to convert a variable value into a z-score. reading from the table or using your calculator or using calculus here, we can calculate that area under the curve above 85 but below 92 is 0.7011. So there is about a 70% chance that a sample mean from this original data set with an unknown distribution, there's a 70% chance that that sample mean is between 85 and 92. Now these problems will feel very similar to the problems where we were just calculating area under a normal distribution. The main thing that's different here is that we're being given information about a random variable, x, but then we're answering questions about a different random variable, x bar, the set of sample means. We'll have to very carefully read through these question prompts because sometimes it's easy to overlook small details like the phrase sample mean. This same question could have had a completely different answer if it had been asked, find the probability that a value is between 85 and 92, rather than saying the sample mean. Because it does say sample mean, we have to create this new random variable, x bar, determine the parameters for that distribution, and then proceed as if we were just working with a standard normal, not standard, but a typical normal distribution.